Hello everyone, welcome to Computer Science 401, lecture number 4. Okay, today we're gonna keep talking about programming language, the languages, different differences between them. Okay, so last time we discussed what kind of types of languages do we have, right? Now let's talk about. I want to show you a couple of examples. Okay, so as a simple example, of the contrast among languages classes, consider the following program. Consider the greatest common divisor. Okay, in other words, GCD. Greatest common divisor. Okay, problem. Okay, so what would okay. So first off, how does the algorithm work, right? Algorithm. Okay, to compute GCD of A and B, so A and B are numbers. Check to see if A and B are equal. Okay, if so, print one of them and stop. Okay, that makes sense, right? So if you have like 5 and 5 or 10 and 10, of course GCD will be 10 or 5. Okay, otherwise, replace the larger one by their difference and repeat. Okay, so that is how it works. Let's give an example. So for, I don't know, 40, let's say 40 and 10, right? So if I have 40 and 10, okay, so they're not the same, right? In this case, what are we doing? We're replacing the largest by the difference, 30 and 10, okay, same thing, not the same, 20 and 10, same thing, not the same, okay, 10 and 10, okay, and in this case, we print out 10. So 10 will be the greatest common divisor. Okay, so now let's try to solve this one using C. So C code. Okay, what is that gonna look like? So int GCD. Okay, so int means return an integer. GCD name of the method, right? Int A, int B. Okay, so maybe like this. And then here, while A is not equal to B. Okay, while this is not true, if A is greater than B, then what? Then A is equal to the difference, right? A minus B. Okay. Um, else B is equal to B minus A. Okay. And that's pretty much it. So while they're different, we're gonna do that, and once they're the same, we're gonna just return either A or B. Okay, let's say A. So that's what it looks like in Java and C code. Okay, like in all the von-Neumann languages, object-oriented programming languages. Okay, so there is no surprise here. Now let's talk about scheme code. Okay, so this is going to be the function language. Okay, so again, everything is a function. So the only thing we basically define is a function which calculates the GCD. Okay, define GCD. Okay, and then here, what are parameters for the GCD? Okay, there will be lambda, so anonymous function a, b. Okay, now what are we going to have inside? Lambda ab. Okay, here we're going to have a condition. Okay, so it's kind of like an if statement. Condition. Okay, so that's going to be the body for the lambda function. Okay, Here we're comparing A and B. Okay, if they're the same, we return A. Okay, now if they're not the same, okay, then do this, okay, which means A is greater than B. In this case, kind of like we call the same function on different arguments, right? So we're gonna call GCD, okay, on what? On minus A and B, okay, B, okay, and the opposite, right? So if it's, well, I guess it's else, right? So this is not really needed. Else GCD minus BA, A, okay. Yeah, so that's the scheme code. Now, okay, how many parentheses here? I think here at the end we should have 5. Okay, 1, 2, 3, done, like this, 5. Okay, like that. Moving on. So that's code and scheme. Now the prologue. Okay, so that's a logical language. Okay, so basically here we're going to define a series of equations. Okay, and then whatever fits in that series of equations is going to be our answer. Okay, so here's how it works. The GCD A, B, G. Okay, it's not C, it's G. Okay, is going to be this. So this is assignment. This sign is assignment. Okay, so it's just like it doesn't mean minus. A equals B, G equals A. So that's the first one. Okay, and we're gonna have two more. So if A is greater than B, then C is A minus B, GCD, okay, C, B, G, okay, and here vice versa, right? So if it's the opposite, if A is less than B, then C is going to be B minus A, and GCD, okay, can you guess? It's going to be C, A, G, okay, and that's at the end. Okay. In a functional language, the emphasis is on mathematical relationship of outputs to inputs. Okay. So in other words, the GCD is going to be kind of like a quote, okay, of A and B is defined to be, okay, A when they're equal. Okay, so we're kind of like creating how to say that. So imagine this is the code, and that's kind of how you would read that code. When they're equal. Okay, next, GCD of B and A minus B when A is greater than B, and the GCD of B minus A when B is greater than A. Okay, so to compute, that's still continuation of the quote. To compute the GCD of a given pair of numbers, expand and simplify that definition. Okay. Well, you can say until it terminates. That's it. Okay, now let's talk about prologue. Okay, for the logical rules. Okay, so for the prologue, how would we read that? Okay. The proposition GCD of A, B, G is true, okay, if A, B, G are equal, okay. So that's one, right? Secondly, okay, well, if, okay, so it's the kind of the first rule, okay, that's the first rule, okay, or, so I mean, like, this is true and that is true. A is greater than B, and there exists a number C such that A minus B and GCD of CBG number, okay, is true, okay, or here is a that is the third condition. A is less than B, and there exists a number C such that C is B minus A, and GCD of CAG is true. Is true. Okay. To compute the GCD of a given pair, search for a number G, and of course number C, a various number C, for which these rules allow one to prove that GCD of A, B, G is true. Okay. Yeah. Cool. That's it. That's it. Okay. Is there anything else? No. That's it. Okay. Just a short lecture for you guys today. Hope you enjoyed that. Please send me the notes. Okay. Hope that all makes sense. I'll see you guys later. Bye bye.